In this second half, we are going to create queries using the design view. Using the same tables, I just added some more entries inside the enrolled table and into the user table so that our examples would be better. So to create a new query, we should go through queries, and then we have a bunch of options to create a new query. And today we are going to use the design view. And design view is kind of easier and a visual way of creating actual SQL queries. So in the backend, it always uses SQL code, but this SQL code is automatically generated with the design view. And in the other lab, we are going to create our queries directly using SQL, and it will have more power. And with queries, we would like to retrieve our data in different ways. We might have some restrictions on the values, or we might also see the relations between our data. So for example, now if I go under tables, my users are in a separate table. I have the course names in a separate table, and I enroll my users into courses with these information. For example, I have the code, I have the user ID, but I don't know what's the name of this user ID directly. And with join operations, we can have such queries that show us the name and also the course name of users and courses. So we are going to do that basically. So I should go through queries and click on create query in design view, and this opens a new window. And in this window, again similar to relationships view, we have the option to include as many tables that we want. So let's start with some basic queries on the user table only. We can include more tables to have the relations in between them, but for now let's just include the user table. And I'm going to close this dialog. If I want to open it again, I should go to insert, and I have the add table or query part. So using the user table, I'm going to use it. I see my table's information on top, and on the bottom side we have a bunch of columns and lots of rows. So each of these columns would represent a projection. So with a selection query, now we are designing a selection query, and with a selection query we project some attributes, and each of these columns actually correspond to different attributes, and which attributes it is our decision. So in here we have the table option. So we included only the user table, therefore we can only select the user table. And under the field, if I choose a table, it will list the attributes of that table. And the star means all attributes, but most of the time we would like to choose some specific attributes. So for example, for this column, I could include the user ID. And for the second column, again from the same table, or since I have just one table, I can directly go to the field. Under the fields, if I do not choose any table, it will list all the fields of all the tables, and the table name is included at the beginning. So for example, I can get user name, uname from the user table. And if you click on this table, it automatically assigns it for the correct table. And to run a query, I have this button, Run Query, with the hotkey F5. If you press F5 on your keyboard, it will also run this query and show you the results. So these are my results at top, and any of these windows you can resize them, arrange them so that you have a better view of things. So I directly show my user table, but only the attributes UID and uname. We also had a scholarship attribute, but it is not shown for this query. So this is kind of a different way of viewing our user table. And most of the time we will have some restrictions on our data. For example, let's say it's not that meaningful for this example to put a criterion on UID. So most of the time the IDs are unique and you don't make comparisons based on purely on the IDs. But let's say I only want the students with ID larger than 5. So I can write here greater than 5 as my criterion for UID. So this is a criteria that I put on UID. I can put different criteria for each of the different attributes. but I'm putting it for UID, and the value should be higher than 5. So the results are not automatically updated. I have to run the query again to see the new results, and these are my new results. I see that all of them have ID larger than 5. And for this comparison part, you can have like greater than or equal to, etc. So if I include the equal sign here, it will be larger than or equal to 5. I can also directly write 5 here. If I do not put any comparison symbol for a criterion, then it means that it is looking for the equal sign. So whether I put nothing and whether I put nothing or the equal sign, it is the same. It looks for an exact match. And in here I can also have like different operations. Like I can say larger than 5, for example, and less than 10. This is also valid. If I run this query, now I see the ones that are in between 5 and 10 strictly. And if I want to make an OR operation, I have a bunch of OR rows here. So to make an OR operation, instead of using the same cell, what I should do is, maybe I'm interested in the ones that are less than 5, or the ones that are larger than 10. So to make an OR operation between different criteria, I include them in different rows, and we have a bunch of OR rows that are following the first criterion row. Basically, if I run such query now, I would see that the ones that are less than 5 or larger than 10. So this is one simple example of a criteria, and with the number types and the date types, we have some similar comparisons. So we either looking for greater than, less than, or equal to things. But for text, we have a different one. So for now, I'm getting rid of my criteria. So if I run this query now, I see all of my users. There is no criteria on any of my fields. But for names, for example, so for username, I might also put some criteria. But since this is a text, we are using different approaches for different data types. So for numeric types, date, for example, these are comparable directly. But for text, we are mostly looking for some specific letters in the text. Therefore, we need to use a special keyword as our criteria. We need to write like. So instead of the equal symbol, instead of saying larger than, greater than, we are writing like. This is our keyword. And within single quotes, then we can include some regular expressions. So regular expressions are any text. So it can be Ali, for example. And if I run this query, it will only show for Ali. And on top of the regular alphanumeric keys that we can include into our text, so I can have some numbers. Maybe Ali 3 is also a text, but it's not included in our user table. So therefore, if I run this query, it will not display anything. There is no results for such a query. But with regular expressions, we are also able to include some special symbols. One of them is the star symbol. So if I write within single quotes a star, then this means, so maybe I can open our notepad for it. So what I'm writing is, like, in single quotes, a star. And whether this is uppercase or lowercase, it depends on whether you selected case sensitive text or not. So in our database, it was not case sensitive as far as I remember. So it can be large or small a. So if I include small a, it's the same results. The star symbol means that this star can be replaced by any number of any character. So for such expression, then these will be valid. So AB, in this case, B is replacing the star. It's also valid for ABB or ABBD, because in this case, remember any number of any symbols, BBD is replacing the star. But there cannot be any other letter, so something like BABBB. B cannot appear before A because we are saying that in our string, in our text, the first letter has to be A. So this is wrong. This is not returning for such a query. So all the result I have starts with the letter A. I can also use the question mark. So question mark means, okay, there can be any letter replacing the symbol, but only one letter can replace this symbol. So in this case, AB would be correct. It will return for this expression, but ABBD will not return for this because, okay, B is replacing the question mark, but then there are additional B and D letters, which is not correct. So in our case, in our example, I can write A question mark, meaning that I have to have the letter A at the beginning and two more characters, and those characters could be any characters. So if I run this query, it will return for Ali. If I add one more question mark, I'm basically saying that I'm looking for the names that start with the letter A and followed by any three letters. So if I run this query, now it will return the results Ayşe and Anna. And maybe sometimes I would like to mix and match this symbol, so I can write a question mark star. So in the case of A star, it will return true for A as well, because these star symbols can be replaced by any number of any characters, meaning none is also an option. So A can be replaced by nothing as well, and A will return. But if I include a question mark here, then I'm basically saying that A has to be followed by one character. So my string should have at least two letters. Only A will not be correct in this case. So in here I can write, okay, A question mark followed by a star symbol, meaning that my string should have at least four letters in it. And if I run such query, now I also see Ahmet. So the star is replaced by the last letter T in this case. And we can put these symbols anywhere that we want, but most of the time what we are interested in is, like, maybe we are searching for a letter A in any position. So in this case we can write something like that. We may write A star, star A star. So there could be anything in the beginning followed by a letter A, and then there could be any other letters. So I'm seeing the ones that has at least one A in any position. Or maybe I'm looking for a not so common letter, maybe H, for example. If I write star H star, then it will only return for the ones that include the letter H in it. So when we are searching for some names, we are going to use such regular expressions. And since we are using this on text, I have to write like at the beginning. If I don't write like at the beginning, then this is no longer a regular expression, and it will only look for exact matches. In this case, for example, if I write in single quotes Ahmet, then it will return true for Ahmet, but without writing the keyword like. It is not a regular expression, so I cannot include the question marks and star symbols. They are not they do not operate as special symbols if I don't write like here. I have to write like to apply regular expressions. So going back, remember we are able to search for a letter A, for example, in our name, and For the third column, let's say I would like to get the credits, show the credits. And I can also apply some criteria on the credits as well. So I can say, okay, my credits should be larger than 110, for example. When I run such query, now I see the ones that include the letter A in it. Maybe this is not that uncommon. Let's replace the letter with E. So the data has changed. Maybe let's write M, for example. So we have less users fitting in these conditions. Maybe if I write credits less than 110, then I only have Mary, for example. So we can include different criteria on different attributes. And when they are included on the same line, it makes the AND operation. So I'm basically saying that the username should include the letter M and the credits should be less than 110. I also have the option to include this on separate lines. If I include them on separate lines, then it means a OR operation. So if I run such query, now I have more data. Now what I'm doing is the name has the letter M or the credits are less than 110. So for example, Tahsin doesn't include a letter M in his letters, but his credits are less than 110. That's why Tahsin is included in this result set. And for example, for some of the other users with credits larger than 110, they are included because they have the letter M in their text. And with each query, so we designed our query in the design view, we can save it. So under File and Save, similar to what we did with tables, we can save our queries. Maybe this is find user M, for example, because we include the letter M. Most of the time we are going to write more meaningful query names. But I saved my query, and if I close it now, when I come back into my main window, so these are tables, and under queries I have my query. And if I double click on the query name, since queries are designed to show our data in different ways, remember why we design our queries, it directly shows the results, because I'm interested in designing my query and then I'm going to use it multiple times. So I'm not bothered with the editing anymore. Now I know that my query runs, and for example, I might be adding some new users, so maybe 13 Jack with credits 60, and when I go out of that line, this pencil icon is gone. And then I might go into my queries and run this query again, but remember this was already open. If it is already open, it doesn't run it again. So you either refresh this query or close it and run it again. So I see that Jack is now included as a part of my query. If I want to go back to the design view, I can do it so by right-clicking on the query name, and then I should go into the edit. So remember, this is the same design view that we were designing our query in. So I did not make any changes. I don't want to save it. So we can have lots of different queries, and as a sneak peek, you can also right-click on the query name and edit it in SQL view, and you will see the corresponding SQL query if you go here. We wrote our query using the design view. We actually designed it. We wrote little, it required little typing, but with the SQL directly we are able to write this query. So it is selecting these attributes from the user table and with some where conditions. And the format that is used in base is for attribute names, for table names, you need to include the double quotation. So it does not write user directly, it includes this double quotations. And the symbols are sometimes changing. Remember, in our regular expression, we had the star symbol, but star symbol is replaced by this percentage symbol in the SQL query. So it creates this SQL query automatically. Therefore, it might look sometimes weird if you have lots of different tables, but it does the job. So if you were to write the SQL code directly, it might be looking different, but in our case, it does the job. So let me create a new query again in the design views, and I would like to include more tables this time. I would like to include the user table, so to double click on the names, and also enroll table, and also, for example, course table. So I'm going to close this now. You will see in a similar fashion to relations window that our relations are shown with links. This time we are not seeing the 1 and n symbols, since we are basically designing the query, and these are not actually uh, about the relation. These are included because we have some relation between enrolled and user, but in the query it is making a join operation. So these lines are indicating the join operation. Why they are included? Because we created the relations beforehand. So if you go to tools and relationships, these are our relationships. And query is copying these relationships as a join operation. But in here, you can also delete these links without affecting your relationships. So these are included only for the query. And I might join different things. For example, I might join UID with CID. It's not meaningful, but it is possible to do it inside the query. So you can right click and delete these links. And let me for now have the join operation between UIDs. And since this is a join operation, it doesn't really matter actually. So if you are making left or right joins, it is going to matter which side this is included in. But if it is an inner join, then the part that you start dragging from is not important, and most of in our cases we are going to make inner join operations. But with the relationships, when we are creating the relationships, remember we always start from the parent into the related one, into the child. So in this case, the user first should exist so that I can enroll that user into some course, etc. So if you come to these columns, now if I directly click the field, all of the fields are listed. So it's more meaningful to first choose the table. For example, I want, let's say, the username, and let's say I also would like to see the user's credits. So this is something like scholarship amount. And I would like to also, let's say, see the course name. So it's under the course table. And let's also show the section, for example. So if I run such query, now I will see some results. And these results are making the join operations in between my tables. If I check my tables, I will see that, okay, I have user joined with enrolled and another join operation to find the corresponding courses. And if I look into this table, it is using my table enrolled as a base. So let me show them at the same time. So it is actually using the relationship, so relationship enrolled. But instead of just showing the user ID, I see the name of the corresponding user, which is Ali. And for the CID and section, I'm actually seeing the corresponding name of that course for the database and calculus, etc. So I can use these join operations to see different attributes of my related tables. In this part, I can include as many tables that I want. So in our ER diagram, we could have a chain of attributes and relationships. For example, user is enrolled to a course, and that course could be taught by a teacher. So if I include all these tables with the relations in between, then I can show for each student which teacher is teaching that course, for example. And again, we can have different criterias for names, for numeric data, etc. Maybe I'm interested in the students that have credits larger than 130, for example. I can write larger than 130. And if I run such query now, I'm also making a condition on my credits. So it makes the join operations, but then I only see the ones with credits larger than 130. And one important thing is we have these lines with inner join. We can change the join type, but most of the time we don't need to do in this course. We make the inner join operation most of the time. But one other thing that we can have is no line between different tables at all. So in this case, now I'm going to run such query, and the results might look weird. And to be able to make more sense about the results, now I'm going to decrease the number of tables first. So let's say I have the user and enrolled tables, and I don't have any link in between. And let's get rid of this criteria, and let's say for the user I include the UID, and let's also include the UNAME, and from the enrolled table let's include the corresponding UID, and in the enrolled table let's also include the CID, and let's run and see the results. So if I look back into my user and enrolled tables, I will see that I have users starting from 1 to 13, and in the enrolled table what I have is a combination of UID, CID, and section. And in the results I will see that, okay, UID 1 Ali is matched with 1, this one for CS281, and then Ayşe is matched with the second one. And if you follow, Ali is matched with 1 again, and then Ayşe is matched with 2 again, but this time for the course ID math. So the users, okay, are matched with every other entry inside the enrolled table. So it's matching for every other combination, and it's actually making a cross product. And if you check the record number here, it is 260, and in our user table we had 13 rows, and in our enrolled table we had 20 rows. So a cross product between these two tables will have 260 different results. So in here we are basically seeing that maybe if I don't include the other parts, it will be easier to see. If I just include the enrolled and the course ID, and for the other columns I can delete this field name so that it's not included. If I run this now, it will be, I think, better or easier to see that each user from 1 to 13 is matched with CS281, and then Math 101, and then again CS281, because in the enrolled table the courses are starting with CS281, Math 101, and then CS281. Maybe an easier view would be without the enrolled table, but with the course table. So if I include the course table, and let's say from this course table I would like to include the CID, and also from this course table I would like to see the section. In this one I will see, I think, more easier that each user is matched with the CS281 section 1 first, CS281 section 2, then Math 101 section 1, Math 101 section 2, and Turkish 101 section 1. And in this case, since we had 5 different courses in the course table, we have 65 rows of data. So why we need to use such thing? So first, let me show the join operation. So if I connect UID to section, section is numeric, remember UID is numeric, I can make a join operation, which is not very meaningful, but if I run such query, I will see that UID 1 is matched with section 1, and for UID 2 it's matched with section 2 of CS281, and for Math 101 and Turkish 101 it's also matched with the UIDs of the corresponding users. I can make a join operation if I want. But why would I need the Cartesian product? Sometimes we might need to inspect within the same table, for example. So I have the user table. If I run such query, maybe it's a good part to see the error. It's saying that, okay, you are trying to get something, but that column is not included. CID is not included, is saying. Since I'm trying to show CID, then I need to get rid of this CID. And if I run this query, I see my user IDs. But let's say I would like to see the users that are getting the same credit. So going through insert and add table or query, I can include a second instance of the user table. So it will be named as user underscore 1. I can include any number of instances from the same table. And you can right click and delete those instances from the query. It is not deleting your tables. And under this area, I can then refer to those different instances. So I can say, okay, user 1, it's a different instance of the same table. Let's also see the UID from here, for example. And if I run such query, I see the Cartesian product between those two. And let's say I would like to include the credits as well, because let's say I'm trying to find the matching credits, so I can write the credits as well. So there is no problem with this. If I run this, it is also projecting the credit amount. And I can also have some criteria for the credit amount. So let's say in this case, my criteria for credits of user, so let me fix this one to user. So this is credits from user, and this other column is credits from user underscore 1. And for the criteria here, this time in the design view, to refer to table names, for attribute names, we need to include the square brackets. So in here I can write user underscore 1 in square brackets, meaning that this is the name of my table. It's not a string, it is going to be an object in my database. And the dot sign, meaning that I'm interested in something inside this table. Again, the square brackets, and then I can write credits. So let me show it in a larger view. So the table names and attribute names are included inside square brackets in the design view. But if I were to write this in SQL directly, in the SQL part, I need to use the double quotations. So it is one difference, and this is converted automatically into this kind of writing on the back end. So let me check what I'm doing. From the user table, I'm showing UIDs. From the user underscore 1, the other table, I'm also showing the UIDs. From the same both table, I'm showing the credits. But for my credits in the user table, I have a criteria. Remember, if I don't write equals here, it is automatically trying to find the equal ones. I'm saying that, okay, the credits of this user should be equal to the credits of the other user. If you check this table, sometimes we have equal credits. Since I wrote by mistake for both of the tables user underscore 1. Let me run the query for the fixed version as well. You will see that 100 is matched with 100, 100 is matched with 120, etc. And then when I include this part, it will only return the ones with equal amount of credits. Now if I run this query, you will see that for the same user ID, it is matched, which is trivial, right? The same user has the same credit amount with himself. But for different users, so user 1 and 5 has the equal credits as well. For example, 2 is matched with 2. It's trivial, but 2 is matched with 6 as well, meaning that these two people are paid the same number of credits. And to make things more interesting, we can remove the same users. So under UID part here, I can remember, similarly I can write, okay, user underscore 1 in square brackets followed by a dot, and then in square brackets as well UID. This will mean that UID of user should match with UID of user underscore 1. But in this case, I want the ones with different UIDs, because if I'm seeing the same UID in the result set, that means that this is matched with the same user. So the same user is paid the same amount of credits if you compare it to the same user, which is not what we trying to achieve. We are looking for two different users that are having the same amount of credits. And I need to use the not equal symbol, or different than symbol, which is this one. So we show it with these characters, which means not equal to. And if I run this query now, then I only see the different users. So 1 on the left hand is matched with 5 on the right hand, and I also see the vice versa. 5 is also matched with 1, which is correct in this case, because we are making this inner join operation, or sorry, we are making this Cartesian product operation, and we will see the ones with matching credits, and we will see the ones with different UIDs. Maybe I would like to get the user with the higher UID on left side. So rather than saying not equal to, I can say, okay, the one on the left should be strictly higher than the one on the right. Then I will not see those duplicates as well. And let's say that I would like to see the names of these users. So from user table, I can include the uname, and from user underscore 1 table, I can include the uname as well. And if I run this query, now I will see that Ali and Ali. Did I make a mistake? Let me check my user table. Are there two different Alis? No, in this case. Or are we using different tables? It's a no again. But oh, okay, I again choose the wrong table on this left part for Aisha as well. It was the same. And if I run it now, John and Ali, John is with user ID 5 and Ali is user ID 1, and they are getting the same credits, although they are different users. And it is again the similar for Kemal and Aisha, this time for credits 120. So let's also save this query. Maybe this is called same credits. And let's do one final thing, going through queries, and maybe for a new query for the users. Let's also include the enrolled and course tables. In this query, let's say I am showing the username and the grade from the enrolled table. Grade is included in the enrolled table. But then since we are making the join operation, the CID of enrolled will be same with the CID of course, and sections will also match. For example, for UIDs, if I would like to show the UID, since I'm making the join operation already, I can get the UID from user or UID from enrolled. It doesn't matter which one I'm getting. Let's show the course ID and also the section from the course tables. So if I run this query, it is basically showing which user name is getting which grade from which course and section. And sometimes we are interested in some criteria based on a value. So let's say I would like to get the credits into the picture as well. And I would like to put some criteria on my credits part. Let's say I'm only interested in the ones that are paid more than some value. And for that value, I can directly type in this window. But remember, when we are running the query, we are going to most of the time save this query. So credits limit, something like that, for example. I'm going to save this query. And under this queries part, I will double click on it. But if I want to change my credit limit, I need to go into the edit part again and change this criterion, which is not that a good approach. For such cases, if the value can change, we might use parameters. And we show parameters with this colon symbol. So followed by the parameter name. I can write param name, for example. It can be anything. So in this case, let's say credit limits, and for parameter names with are similar to our other naming conventions, it's better to leave no empty spaces. So now if I run this query, so let me also show this in a bigger view. I'm saying it's larger than some parameter. The value is going to be an input from the user when this query runs. So I'm going to run this query. Now it says that there is some parameter input for this query. It asks for a parameter, and I can write the value, for example, 100. And if I click on OK, then I will see the results for that value. And if I save this query with Ctrl S and close it, in this part I can double click on my credit limit query, and it will first ask for this parameter, for example 140. Then when I give this parameter, it will show me the results, which is a more useful case for us. So maybe we are the designer of this database, we are designing it for some user, and that user will be able to use it easily, as long as they know they should include the values for the parameters. So for that, so using some meaningful parameter names would be useful. And going back to the edit view, we can include as many parameters that we want. So maybe we would like to also have some restriction for the course ID, or maybe in this case, let's say for the grade, because course ID is string, right? For the grade part, let's say we would like to see the ones that are larger than the grade limit. It's yet another parameter, and when I try to run this query, then I need to fill two different values. So credit limits could be 100 and grade limits could be something like 50. So if I click on on my different parameters, I can see the values, and when I click on OK, then now it will show me the results. I can also leave this empty and try to run the query, which will not show me any results because, like I'm saying, greater than null, which doesn't include anything at all. So basically, we are able to create some basic queries. So I'm going to save it as well. We are able to make join operations between different tables, and let me also show the relationships view that nothing has changed in this view. While we were deleting some links, we were doing it for the queries specifically, not for our relationships. And one thing to remember is that we have an SQL code that is generated automatically for each of our queries in design view. So we made this in the design view. It is projecting a bunch of things. So this is our parameter, for example. We are saying the grade should be higher than this parameter and some other conditions. We are making the join operations, for example. We did not specifically said that it should be a join operation, but if you open this query in the design view, you will see that through these links between our parameters, it is making the join operation between the user's UID and UID of enrolled. And if you check the SQL view, so I need to close this to see the SQL view. If you check the SQL view, it is matching the UID of enrolled with UID of user, and on the other side it is matching the CIDs, and it is also matching the section numbers at the same time. So the design view helps us for our introduction, but to have more complicated queries, sometimes it is not enough. So that's why we are going to use the SQL queries as well in the next lab. But one more thing before we end this is, remember in the ER diagram we can have one-to-one, many-to-many, and one-to-many queries. No, sorry, relations. So I'm talking about relationships. With relationships, we can have one-to-ones, many-to-manys, and one-to-manys. And while you are designing the tables of your relationships, so in this case, enrolled is a table for a relationship. If I go into the edit view, I set my primary keys so that this is going to be a many-to-many relationship. So if my primary key is the combination of all my foreign keys, then this means this is a many-to-many relationship. In the case of a one-to-many relationship, I only need to include the non-repeating foreign key as my primary key. So for example, let's say that in our database, each user can enroll to at most one course. So let's say a user is going to enroll at most one course, but in a course there could be many users. How to do such thing, how to enforce such thing, let's say. Right now, if I look into my enrolled table, I see that user ID, the same user ID, could be repeated more than one time. And the combination of CID and section, so 281.1, can appear multiple times. But what I want is, for a specific UID, there should be only one course. But for the same course, there could be multiple users. Since for this data set, this is not going to be valid, so I have repeating users, right? It will not valid for my new rule. I'm going to delete all the rows in my enrolled table, because I'm going to put a new rule, but my data, current data, is not following that rule. So you need to be careful, so that you should always make sure that when you are putting some rules, the data you already have should follow those rules. So since we are expected to design our tables first and populate them later on, you can like design your database as you want without thinking about the data. But since we are making some changes beforehand, that's why I need to delete my enrolled entries. Right now, it's many-to-many, because from the user side, I have UID, which is a part of my primary key, and CID and section are coming from the enrolled side. They are also primary keys. And if I make the UID single primary key, and let's save this. So right now, my only primary key is UID. Therefore, if I open my enrolled table and try to add some new data, let's say for UID 1, CS281, section 1, some grade. UID 2, I should be able to enroll into the same course. Maybe change the grade. So some other user to some other course. But I should not be able to add the same user to a different course. For example, in this case, let's say Turkish 101, section 1 with some grades. When I try to go out of this new row, when I try to get rid of this pencil icon, it will give me an error saying that duplicate primary key. Why? Because UID is my single primary key and it cannot have duplicate values. So this is how I make one-to-many relationships. And I need to change the UID, or you can hit the escape key to get rid of that. So I'm going to remove this again because now I would like to show you how to do a one-to-one relationship. Going back to the edit of the enroll table, for a one-to-one relationship, UID should not duplicate, it should not have any duplicate values. And the combination of CID and section should not have any duplicate values as well. So basically we are saying that one user can enroll to one class only, and in one class there could be at most one user. So we are not talking about the total participation, therefore we should speak using at most. At most one user can appear in a course, and a user can enroll to at most one course. This is what we are saying. How to do it? So I already made UID the primary key, and I also need some constraint on CID and section. I should be able to say that these should not have any duplicate values. And to do that, I should go through tools, and in here I have index design. And using this index design, we are actually able to set the primary keys, etc. But now we are going to include a new index. So I'm going to click on new index. So I have multiple things here because earlier we made different kind of relationships here. Or let me say it like that. We have some existing relationships and we have some primary keys for enroll table. And some of these indexes are created automatically. But now I would like to create a new index. So I can write any name. Let me write unique ones. So the combination of these attributes that I will write here will be unique in this case. And I want CID and section, combination of these, to be unique. So what does indexing mean? To be able to follow whether there are duplicates or not, whether something is unique or not. We need some way of storing the data, right? And these indexes are basically that. So we store the combination of these in an easier accessible manner so that we can enforce that these are going to be unique. So I'm going to save this and close this, but be aware, if you try to change one of the existing ones, it will give you an error. So make sure that you are including a new index if you would like to enforce uniqueness on CID and section. So I'm going to save this, close it, and if I come to here, okay, user number 1, CS281 1 with some grades, and user number 2, for example, for Maths 101, section 1 with some grades, and then I should not be able to add the same user to a Turkish class. This is giving me an error. It says that it will create duplicate values for UID. Hitting escape key on my keyboard. I should also not be able to have a different user to the CS281 1 with some grade. This is a different user, but the same course. So when I try to go out of this, it is saying that violation of unique index. We give this name unique once. It will create a duplicate value for that. But if I change the section number to 2, since as a tuple CS281 and 2 does not appear in my list twice, then this is no problem. But then for such a user number 4, I cannot have CS281 2 again because now it will have a duplicate value. And this is basically how I enforce my relationship to be one-to-one. So with many-to-many, every foreign key is the part of primary key. With one-to-many, the one that does not have duplicate values is going to be the primary key. And with one-to-one, we should of course set some site as the primary key. In this case, we made the foreign key that references user the primary key, but it could be reversed as well. But for the other side, we should have a unique indexing, and we already show how to do it. And in the next lab, actually we are going to upload one more video that shows how to create a database for the ER diagram that we give in the first lab. So that will be like an additional supporting video so that it will help you in the projects. But in the lab 3, we are going to start writing SQL queries directly.